We're here today to have a conversation about Bifrost and LLM Gateway that we've built here at Maxim. It's for the enterprise scale for governance and reliability. I'm Anayata, a part of the founder's office here at Maxim, and we are joined with Dhwanil, one of our founding engineers for this conversation. So I think we can get things started. How are you, firstly, Dhwanil?
I'm doing pretty good, just a bit exhausted because I've been coding throughout the day, but yeah, pretty excited to talk about Bifrost with
Yeah.
you. Yeah.
Wonderful. I think we can get started with talking about getting a general sense of the pain points that teams are facing today, especially with their production LLM deployments. What have you seen with your experiencing having conversed with teams working at this scale?
Yeah. So taking a real life scenario, nobody's actually working with a single model that's there, right? Everybody's trying to use a lot of models, and realistically speaking, Anthropic is a bit notorious for just rate limiting everything that's there, right? So, but you cannot afford to have a lot of rate limits that's there on your application, right? So you need some way to. So this becomes a big pain point as to how you could easily switch between different models and different providers. Google also provides with Claude deployments. Anthropic also provides with the same. But when you're trying to use only Anthropic versus when you're only trying to use Google, like there are some sort of differences that stay within your code base, and you have to keep maintaining it because since they are different providers, they expect different API structures, and nothing is automatically taken care for you. Like if an Anthropic query fails, do you fall back to Google? How do you integrate those things into your code essentially? So I mean, this is one of the bigger points that I've seen people face a lot of issues with, is just generally trying to handle a lot of these complexities on themselves, where there could be a standard that could exist that does these things for them.
Right. Taking it from that, so what does the standard actually look like?
Yeah, so it generally this is what Bifrost provides for you. Is essentially we are an LLM gateway. What that is essentially you get a unified interface where you just use that singular interface, and you are able to hit any model with any provider that you wish to. Right. So uh, Bifrost essentially just follows OpenAI's chart completions APIs and responses APIs. So using that same structure, you could hit Anthropic, you could hit maybe even DeepSeek or like some lesser known models and everything, and we handle everything internally for you, where essentially everything gets converted into the request body that the provider expects. We send it to them. Once the request comes back, essentially we convert it back to our own unified interface, and then we send it down back to you. So you essentially never know about the differences that are going behind the scenes. What you know is just sending requests in a singular form, getting that request in a singular form, and that is all that you have to maintain in a code base.
Mhm.
And taking care of all the fallbacks that's there. If my Anthropic query fails, try it 3 times and then fall back into Google, and then do something else. So like these sorts of smart routing that we say is also what we also handle for you in all of those cases. So you never have to worry about your user getting a rate limited response or like some bad model response because you weren't able to figure out how fallbacks from one thing to the other takes place essentially. Yeah.
Right. So talking about Bifrost and your answer, it seems like a rather iterative process when there is still a lot of back and forth that's going on. So today in the market for these issues, there already are a lot of approaches. There are DIY approaches. There are under other vendor solutions that are being offered, open source solutions. So why is it that we've built Bifrost, and how is it that we are adding value to this solution and making it different than what is already existing?
Yeah, so essentially DIY solutions have been existing, like all the indie developers out there, they might be using essentially all of their DIY stuff itself, but most enterprises and companies that I've seen are, a little bit tipped towards using LLM and other solutions that exist in that space. And LLM is a good product. They have had a lot of day one support for everything, and they have mostly set a lot of standards, but I think their ways of choosing to build upon Python has, had some sort of block in order to, get over. So, like one thing that I could think of is like they have a lot less amount of throughputs. And when you hit with a lot of QPS, what happens is they start dropping requests. Your success rates are never 100%. They drop at some amount if you're using light LLM in that sense. And so us choosing to build this was just trying to have a lot more standardization in this space and build on top of Go, which is what the whole Bifrost team loves here. So yeah, but Go is a good base to start upon, is because it's not too complex to contribute to, but at the same time you could make it a lot more complex, where you need those performance gains, where you need those little eeks to get you a really good experience going ahead. So this is the main reason why we've decided to essentially build this open source platform. And we are planning on getting a lot more plugins into our ecosystem, and see how things take from there. But yeah, this is the main reason.
Perfect. I think that sounds great, Dhwanil. Let's take a hypothetical. Say I'm a developer using an OpenAI SDK today, and I'm transitioning into Bifrost. What actually changes here?
I mean, that's the best part of Bifrost. With any ecosystem that you're trying to use, we just integrate in the most seamless way possible. Essentially, we have HTTP transport. Bifrost by itself is just a Go library that you could use if you wish to with your Go code directly. But we provide these sorts of transports, where HTTP is the one that we have been working on currently, where we set up a lot of these systems in place for you, where there's a lot of things that already take care of integrations for you. So, for example, you've asked about OpenAI SDK. What we do over there is you just take your Bifrost's deployed, URL, you append a slash OpenAI to it, and then that you set that as your base URL for your SDK, and you're sorted from that place on. And then you could just put anything in a model name. You could just put Anthropic slash Claude 3.5, and we hit that model from OpenAI's SDK. So you essentially don't need to change a lot, just the base URL once you have set it up. And we take care of a lot of things from there on. Also, if you're using Cloud Code, you could also try Bifrost with that. It's just a single line change again.
Great. I think we can delve a little bit deeper into the OSS features as well, Dhwanil. What is standing out? Of course, in general, what we are offering as well, if you can touch upon that.
Yeah, so there are a few things that come to my mind here. One of them being that we provide budgeting built in out of the box. So if you are using any provider or any model and you want to set a budget or a rate limit on top of it, as to like I only want like $20 spent on my cloud deployment, versus I could go up until $50 for OpenAI or something. So you could set all of those things up, which is a really good thing to have, so that you don't overuse your expenses when you're trying to use your models. Another thing that comes to mind is we also have virtual key supports. So what that essentially does is, if you have a lot of customers or a lot of users that are using your product, and you don't want to share your actual keys because you would never want to, right? What you try to do over there at that point is you try to create a virtual key, and then you provide that virtual key to the user that's trying to use it, and you could have all of those limits on top of these virtual keys. So it's not like I'm only setting a limit on top of my cloud uh, deployment, but essentially I'm setting a limit on this particular key itself. And this key can be given to a user, and that user particularly cannot go over, like, let's say $10. If they try to go, the virtual keys limit has been hit and they cannot use more than that. So that is one more thing that we have. So if you are a company that also provides these LLM services for other companies, you could take advantage of these virtual keys that we have. Apart from this, there is a good amount of observability that we provide to you, right? So for each request that comes into Bifrost, we have a separate Go routine that just actually records. Nothing is ever on your hot path. Your hot path is like almost completely clear, as if you're just directly trying to hit your APIs, right? But all of these things happen in the background, and we log each and every request for you, and you have some good amount of analysis on top of what's happening with your request, what's not. There's a lot of filtering if you need to understand during some outage or something, like what's been going wrong, right? The observability provides a lot of things for you over there. And finally, like the main thing that I would like to talk about is like we also provide you with an MCP gateway, right? So the MCP gateway, essentially, MCP is a lot of hype. That's essentially that was a hype. I don't know if it's still going on, but I think it's a good standard for providing tools to these LLMs and them trying to use it, right? But there is no standardization across that place as well, because like providing tools to Claude versus providing tools to GPT models and everything, like that structure also varies a lot, right? So what happens with Bifrost is you come in, you set up your MCP servers, you configure them, you say what you want to expose, what you don't want to expose via the tools, via different servers, and you just configure that and you just hit a request. As soon as you have configured all of those MCPs, what happens is with each of your requests, we attach those tools automatically for you, right? And you can obviously override it per request, always. Like we support everything via some header parameters, right? So yeah, but that is a really really interesting thing to be looking into, is essentially providing tools in a much better manner to all of your models that have been working, and not trying to bang your head against a wall when you're trying to try uh, playing with these interfaces for different models, essentially. Yeah.
Right. I had a follow-up question on the key limits that you mentioned that could be provided. So, like with the URLs that you mentioned, that just a slash and Anthropic slash or OpenAI would change, and that's just a one-line solution. With the keys as well, does the same logic apply where the keys can use OpenAI, it can use Claude, and that can be across for one key as well? And can you limit that, or is the limit for an overall thing or for the divided, like OpenAI has a certain limit, Claude has a certain limit? How does that work?
Yeah, so virtual keys are very configurable to like as much configuration as you wish. You could go down to it. You could just simply create a virtual key, say that $30 is the limit on this, and then that's it. You call it a day, right? So anything that you expose via your Bifrost server can be accessed via that virtual key, and the limit would be $30 overall wherever you try to use it, right? But you could also add on top of it, like OpenAI should be using only $5, or like
Claude should be
Claude
using
should be using like at most like 10 requests per hour or something, because their rate limits are a
bit
lot
high.
more this thing, right? So essentially, you could crack it down as much as you wish to, and you could configure it to your heart's content.
Perfect. But quick question, I would like to know what is one of the features that you like using the most with Bifrost?
Yeah, it's one feature that I almost forgot talking about with the MCP gateway. It's essentially code mode. Like Cloudflare wrote an article on this a while ago, and then Anthropic also covered it. I don't know if they called it code mode or not, but Cloudflare certainly did. Like it's one of my favorite parts of the MCP gateway, because what happens is whenever you connect a lot of gateways, right, to your LLMs, what ends up happening is you expose a lot of tools to your LLM. Now, essentially, they have a very limited context window, and the more amount of tools that you expose to it, you eat that much amount of context window with each turn, right? And that tools goes with each turn that's being done. So what happens is, along with the token usage increasing and that context window being eaten up, you essentially also get a lot of hallucinations from the LLM. Why? Because it already gets all of the descriptions for all the tools and how it should execute it across all the MCP servers and across all the tools, right? And they might not even be, relevant to the conversation that you're trying to have with the LLM. And in many cases, it could also be that there was no need for the MCPs to be there at all. It's just a normal conversation that I'm having with the LLM without any tool calls, right? So what code mode does for you is it essentially hides all of these tools behind a certain set of other tools, right? So what we try to do over there is whenever you connect any MCP servers, we essentially don't expose them to the LLM. We expose 3 or 4 tools to the LLM, and those 3 or 4 tools, essentially what they ask the LLM to do is whenever you want to know about your capabilities, just try to read the file structure of your MCP, right? And so whenever it comes across a thing that it is not able to do, essentially the LLM then calls and sees the file structure. And that file structure is nothing but us exposing MCP servers to them. right? It's just if you have attached context 7 as your MCP server, what we expose it in a file server is context 7 is a folder, and under that there are a lot of files that's there, right? And then there is one more tool where the LLM, after seeing the file structure, knows what all files exist and it can read a particular file, because LLMs are very heavily trained onto writing a good amount of code and navigating a file structure. So this is where these things come into a lot of help to us while we expose it via these you know uh, ropes to the LLM. Is essentially it now knows how to navigate this code base of sorts. It's a pseudo code base, but it's a file structure. So it knows how to navigate that. And then it also knows how to read a file, because we have exposed that as a tool to it. It can read a file, it can see what all tools are available for a given server. And then context 7 exposes, let's say resolve a library or like do a query for me, right? And so those are the two functions inside your file. And now this is the best part of having the code mode, is essentially after reading all of this, after grabbing all the context that it wishes to from a code base like it does naturally, it can write code in order to execute it. And so this is the best thing. Why? Because let's say you have a Google Drive MCP server, and then you have a Dropbox MCP server. You want to shift files from one end to the other end, right? So what in a natural way would be done is the LLM will try to call Google Drive, say list your files. All the files would be listed. It will see all the contents of the files that is also listed into your context, and then it will read everything and then try to make a tool call, including all of the content into the Dropbox create, right? And so what happens is this ends up polluting your whole context, right? Now, let's say, for example, if there was some sort of a prompt injection, it might not be a malicious one, but it just happens to have prompt injected itself, right? The LLM, because there are a lot of docs, there is a lot of text, and so it might deviate from its path of what you were trying to make it do. Is just essentially take it from Google Drive, go to a Dropbox. But as soon as it listed a lot of things, a lot of the context might get polluted. It might lose track of, I had to transfer this, and it might go ahead and do something else entirely. So there are two things that is happening here. One, you're paying a lot of cost. Then there's a lot of context that's being bloated, and there's also one more thing that's happening is the LLM is hallucinating even more when it's trying to use these things in such a huge context window, right? Code mode solves it by it just having to write two lines of code. It's like grabbing docs from Google Drive, just call a method, you get all of these, you map over each doc, and then you insert it into the Dropbox, just maintaining the structures of what each wishes to write. And now what the LLM sees in its context is just that it wrote three lines of code, and then this three lines of code has been successfully executed. That's it. And your whole process gets completed without bloating context, without you having to pay a lot of cost upfront, and
Without
then
hallucinations.
yeah, and without hallucinations, because it never saw what was in there. So this also helps with, if you're concerned about your privacy or something regarding these documents, that you don't want your LLMs to read through these documents but still process on top of it. So this is where code mode really shines, and which is why it's one of my more favorite things to explore using LLMs. I like on weekends I just sit with it, try to see what other things it could do with these things. But yeah.
Got it, got it. Makes sense. Sounds great. Now that we've delved deep into the OSS features, can we talk a little bit about the enterprise features? So, when teams are transitioning into the enterprise tier of things, what does Bifrost look like to them?
Yeah, so essentially how Bifrost makes money. Yeah, so we have a lot of other features on top of OSS, right? It's essentially we have semantic caching on top of it. Essentially what semantic caching is, in a very quick term, is you sending a request, right? For the first time, whenever you're sending something to a model, what it does is it responds back. If you say hi, it says hello. But if another user again sends hi, it again has to burn through tokens, send you back hello. And that is also eating up your cost, right? So what semantic caching does is, if it semantically finds two questions to be the same, we have cached responses ready to go back to them. So what it does is, whenever the user says hi, the first time we don't have the cache, we hit the LLM, you get back hello. We store this vectors into a vector DB. Next time a hi comes in, it matches with the semantic cache. we grab the already cached response, and then you get that back, and you never have to make the round trip to OpenAI. This helps you save on cost, and it also helps with the latency a ton, because there is no inference of sorts happening here. It's just static, one shot, just getting a response back to that. So that is one thing that we have in enterprise. One more thing is we have adaptive load balancing, right? So adaptive load balancing is necessary because of the point that I mentioned in the very beginning, where you have to keep on deciding as to where you fall back, what do you use, which models are performing the best, in terms of latency and cost, obviously not in terms of intelligence, like that those things are very hard to quantify, is what I would say. But as far as latency, costs, errors, and outages and these things go, we have a very intelligent load balancer that very evenly spreads the load and distribution across all of the things that you provide to it, across all the providers and across all the models, if you wish for that to be the case. And you would see that over time, all of the usage across everything has been the same. But in case if something has suffered an outage, or in case that something has a lot of latency or is experiencing a lot of errors, we would suddenly stop sending a lot of requests back to it,
It
and it will
adapts to
start,
what is
yeah,
happening.
it will start dying, and it'll go back to zero, and everything else will then evenly spread the distribution among themselves. But we never leave this guy out, because obviously it's a part of your infra. So in between some requests, we just try to ping it for health. Is it recovering, is it not recovering? And then it has a lot of momentum in case it is recovering, as opposed to others, so it gets a lot more traffic as opposed to the other ones, so that the distribution still gets to an even distribution that's there, right? And so this is how we take care of distributing your load across everything, and not ever having you have to suffer through trying to manage what fallback should I go for, what's going to work for me, what happens in case of an outage. Like, everything over there is taken care for you. And in case there are recoveries that happen, like Anthropic had an outage for like 5 minutes, they came back up, and now we recovered that back as well, and now it's in the pool to evenly distribute the load across that, right? That's one more thing. Yeah. So on top of this, we also have governance and guardrails. So what governance essentially is, just your usual enterprise stuff. It's SAML SSO login and your RBAC stuff, where you restrict users or permit users to have certain access to certain parts of Bifrost, and those sorts of things. And what guardrails essentially is whenever you don't want certain PII or stuff to leak into your responses, that's when you use them. They essentially redact it or just block the request altogether, and we enable you to use that. You could use AWS Bedrock or Azure or Petronas AI, like other such guardrail providers that you have. So that's what guardrails is essentially. And finally, we also have cluster mode, where you could deploy a lot of instances of Bifrost, and they could play with each other whenever a request comes to a particular node inside the cluster. They gossip within each other. It's a peer-to-peer sort of a communication, where the information spreads from one to the other to the other to the other, and it just goes on like that, right? And so that is what cluster mode is essentially. You have a lot of deployments of Bifrost, so that you have a safety fallback sort of a thing, so that in case one of your node goes down due to some out of memory things, or like anything that could be happening, you have other nodes to rely upon. And it automatically takes care of balancing itself, discovering other nodes in the cluster, and everything from there on. So that is what cluster mode is all about. And on top of it, we provide the features like audit logs and some other stuff, which you guys could just visit the website and have a look at those features. Yeah.
Right, Dhwanil. So, what I've understood so far from our conversation is that Bifrost is working towards the performance and scalability of AI applications. But how do I ensure the quality of the responses as well?
Yeah. So when it comes to the quality of responses, right now you've built your application for scale, and now you're trying to improve the responses of it. So whenever a user asks for something, in case like there's some information, you want to ensure that your applications are calling the right tools, have the right context, are prompted in the right way to give the right responses. And this is where Maxim comes into the picture, right? Because Maxim is the place where you are able to simulate, evaluate, and observe all of your agents, right? So for your whole agentic life cycle, you could actually integrate Bifrost with Maxim. We provide a first-class plugin which actually logs all of your LLM calls that come into Bifrost into Maxim, and then you can have evaluations on top of these logs, and you could sample some logs and see how your applications are performing, what you could do better from there. You could start curating prompts from your logs that you're getting into Maxim, create data sets, and do the whole observability stack there. If you guys want to know more about Maxim, please check out the channel. It's superbly dope stuff that we do over there as well.
Right, Dhwanil. I think it's been a very fruitful conversation. But before we wrap things up, is there something that you'd like to mention to platform engineering teams that they can take away from this conversation?
Yeah, so like there's a lot of difference between building something for like 10 people and building something for 10,000 people, and most platform engineers are working for the latter part of things, which is where Bifrost helps you a lot into scaling your applications to that level, while also serving for a low traffic as well, right? But for the existing solutions that exist in the market, a lot of the solutions that exist, maybe aren't that capable or lack features or just aren't that performant. And so this is where I would like encourage them to try Bifrost, see things over there, get a feel of how we've tried to design things that make it a lot more easier and a less of a headache for you to host these infrastructures in between the other infrastructures that you're trying to head for, the AI gateways of the world. Yeah.
Okay, wonderful, Dhwanil. I think this has been a really fruitful and wonderful conversation. And I think it's a good time to wrap things up as well. But the main thing that I am taking away from this conversation is I'm going to go home and try code mode today. And of course, as always, we encourage folks to come on and build cool stuff with Bifrost. We have a lot of resources linked in the description, and obviously, the comments are open for your thoughts and suggestions as well. But yeah, anything that you would like to add?
Yeah, like whatever you guys are building, please do share it with us in the comments. We would love to see what you guys are up to using Bifrost. And the GitHub is also open source. We have a lot of community aspect to the thing that we're building over here. So I would also encourage you to open issues, come play around with the product and engage with the community a lot. And do give us a star on GitHub if you like our project.
Perfect.
Subscribe.
Subscribe. Yes.